Welcome, Stephen Mathezer. Welcome to B-Sides Vancouver 2022, track 2 and day 2. Stephen's going to talk about raising the bar of ICS security. Welcome, Stephen, and take it away.
All right, thanks very much. Welcome, everyone. I know we're getting towards the end of day 2, so hopefully you've been enjoying lots of good presentations, and hopefully I can add to that a little bit as well. We've been talking, I think, more and more about industrial control systems and ICS security, and there's lots of stories, some of which in the news, some of which I'll talk about. But I don't know how far we go with practical, actionable advice out there for folks who want to do better for security in industrial control system environments. I know, in my experience, everyone acknowledges that it's a problem and doesn't want to touch it with a 10-foot pole because of mysterious bad things that might happen if we touch those systems that have been running untouched for the last 40 years or so. So I'm going to try and introduce the landscape a little bit here and then talk about some of the things that we can do to raise that bar. Yes, once I get focus, there we go. I think we can all agree that when we're talking about ICS security, we're talking about protecting the real world, right? I pulled a bunch of words from various definitions of industrial control systems. These are the words that popped out, and on the left we've got some of the definitions, or at least fragments of some of the definitions around industrial control systems, just so we know what we're talking about here, that we're all on the same page. As I mentioned, we're talking about computers or devices or systems, cyber systems, electronic systems, whatever you want to call them. I already said cyber, there you go, that can influence the real world or bridge the cyber world with the physical world. Another way to look at it is we have systems or technology that can manage, command, direct, and regulate behavior, again, kind of tying into the real world. Very, very often we are talking about systems of systems. We're not talking about a single device in isolation. We're talking about systems that manage systems of systems of systems. It's very much a tiered environment. Other definitions I've said is the combination of hardware and software and network to, again, influence the real world. And of course, what are we trying to do here? This is the actual goal, which is automating an industrial process, which could be anything from, water to electricity to oil and gas to manufacturing to pharmaceuticals to any number of other sectors as well. In fact, one of the first topics or sectors that comes to mind is critical infrastructure, right? That is really our primary focus, I would argue, when we talk about industrial control system security, because we have industrial control systems in a lot of sectors that are critical to our daily life. The 16 that are on the screen right now are the 16 critical infrastructure sectors as defined by the US government, and some of them might be a little bit surprising, right? We see financial services in here, but again, if we can't access money, we might have some problems day to day, right? We've got healthcare in here. We've got manufacturing, as we've seen with a lot of the supply chain issues we've had over the last few years. We can do without certain things arriving on our doorstep the next day, but there's a lot of products that are critical to our everyday life that come out of that manufacturing sector. And there's a whole bunch of other ones here that you can see and probably make a whole lot of sense in the context of critical infrastructure. The definition from the US government is sectors that are so vital that their incapacitation or destruction would have a debilitating effect on security, national economy or economic security, and national public health or safety. So if we have disruption in these sectors, it's going to have a real material impact on our daily lives. And not just an individual's daily life, but everyone's, nationwide or in a geography. That means, obviously, we need to do something to protect these sectors, because every last one of them has significant automation in some way, shape, or form. And that's what we want to protect. So when we talk about a control system, this is forgive my PowerPoint artistry here, but this is a very basic model of what we mean when we talk about a control system. We have a loop. We have a process. It's doing something. It could be manufacturing. It could be transmitting electricity. It could be anything. And we have a controller, some piece of technology. And that controller is going to send output to what we call actuators, but that could be anything. That could be switches or valves or motors or burners or anything that we can use to interact. This is our bridge to the real world. So a controller is going to send commands or direct actuators, which will then have a change in the process, which we measure using sensors, providing input back to the controller, and ideally it works in a relatively anonymous fashion in a loop here, keeping our process healthy, doing whatever it's supposed to be doing on a daily basis, or daily basis, minute by minute, second by second. We have other pieces here though. We have engineers who help design and implement. We have operators operating day to day, technicians maintaining, and they may interact directly with the controller, with the sensors, with the actuators, and make sure things are operating as they are supposed to. And we also have supervisory systems that maybe those people might interact with, or that might interact with that controller or with many controllers, again, systems of systems, and try to coordinate multiple controllers or provide that high-level oversight in terms of what's going on. So when I talk about a control system, at its most basic, this is what I'm talking about. We have sensors that are watching or measuring a process and providing data and input to a controller that then has a program and allows it to determine what needs to happen next. It's going to send commands or output to those actuators, which will then adjust the process as necessary. So what can go wrong? What is an attacker trying to do here? Well, an attacker wants to get in a position where they can disrupt this process in some way, shape, or form. That can happen lots of ways. If an attacker is sitting, we'll call it in line or on the network, or has an ability to interrupt this communication that normally the humans would be having with the actuators, well, they can change the actuators. Maybe they can interact with the controller directly or indirectly, and that can change output. And maybe that can change the view of input that is sent up to supervisory systems to conceal an attack, or just adjust the sensors. You know, the old TV show with the bank robbers or whoever in the building and looping the cameras, right? Maybe an attacker can do that, or they can reach right in from the top and affect multiple systems. An attacker wants to get to one of these positions so that they can have whatever impact they want to have on the process. Shut it down, gain an economic advantage, blow something up, whatever it is. This is what we're trying to prevent. We're trying to prevent attackers from getting all the way to the point where they have access to control the actual controller, control the process, control the sensors, the actuators, and take an action that impacts that real world. That's what we're trying to protect against, which is what I want to talk more about. ICS attacks, prior to 2010, there probably wasn't a lot. I'm sure there were things going on, but nothing at a scale like we see today. Nothing that was truly remote and automated and widespread. As I'm sure many of you know, Stuxnet came onto the scene in 2010. And on this slide, I've bolded the attacks or the incidents that did have or potential to have direct impact in the real world. Some of these other attacks had either they were gathering information, or they weren't manipulating the process directly, but they certainly had impacts to industrial organizations. Dooku and Flame were more intelligence gathering. They collected information that could be used for future attacks, but Shamoon took out some 30,000 odd endpoints in Saudi Arabia, but not directly affecting the process. They took out the vast majority of the systems within the organization. Dragonfly was a campaign. Havix was a tool. It was, again, mostly just looking for information, but it had impact. It was able to overwhelm systems intentionally or accidentally. This was one of the earlier supply chain attacks that we saw as well. It was Havix was embedded in legitimate software that people were downloading onto their ICS networks. German steel mill was just run-of-the-mill malware, but as we think we know anyways, the operators ultimately decided to do something about it and brought their own mill down in the process. Black Energy, there's multiple versions, but Black Energy 2 specifically attacked controllers. The GE Simplicity and some Siemens controller or HMIs as well. Sorry, not controllers, HMIs. Indestroyer 1 is now called Indestroyer 1 because we have Indestroyer 2. That was the blackouts in Ukraine in 2015. 3 hours without power to some 200,000-300,000 people. That was truly real world, impacting a lot of people, malware. And they came back the very next year and attempted something similar that was less successful, but was still directly impacting control systems. 2017, back to Saudi Arabia, attacking safety systems, our last line of defense to make sure nothing bad happens. Well, they almost were taken offline, enabling significant attacks. And then, I don't know, there were no major newsworthy attacks. I'm sure lots happened between 2017 and 2021, where we had Oldsmar, the water treatment, and Colonial Pipeline attacks. Again, obviously major impact, but not direct manipulation of the real world. And I'll talk about Indestroyer 2 and Pipedream here briefly on the next slide. So we are seeing more and more attacks that are, I don't want to use the word advanced, but they are more advanced, and they are more and more targeted at the real world, at having those real world impacts. The new folks on the scene, Indestroyer 2, also from Sandworm, who are behind several of these attacks. It was used against a Ukrainian energy provider, and it was talking IEC 104, which is an industrial protocol used to communicate with controllers in primarily electric, in the electric sector. And there were some additional pieces like wipers that came along with it, but again, getting more and more sophisticated, able to actually talk ICS protocols. There's some modularity. It could be used, it wasn't set up that way, but could be used with other protocols as well. And then we saw Pipedream, which takes this even further, was discovered prior to deployment. So it hasn't been used against anybody that we know of, but it was tailored to impact specific controllers, specific servers. And OPC UA is a protocol that is multi-vendor, multi-environment. It can be used to impact a whole bunch of different environments, and it had all kinds of capabilities. It was deemed a Swiss Army knife. The good news was it was discovered before it could be deployed, which allowed us to get indicators of compromise and some awareness out there to potentially mitigate an attack. All of this goes just to say that we are seeing significant attacks against ICS. And we'll talk a little bit about what that means to us in a minute. How are attackers going about doing this? I talked about a few slides ago, being able to influence those sensors, those actuators, those controllers, and so on. But it's not that simple. And I think that's something we sometimes lose sight of. There is, SANS put forth an ICS kill chain. This was quite a few years ago now. Obviously loosely based on the Lockheed Martin kill chain, but ICS networks are different. There's often, very, very often, two stages. The attacker has to get to the point where they have access to an ICS network. And that may happen many, many ways, but often that is by coming in through the internet or through phishing, etc., into a business network, and escalating privileges, moving around the business network, exploiting vulnerabilities, installing C2, and getting to the point where they can commence an attack against likely the ICS boundary or the edge of the ICS network if there's some segmentation there. And then get into the ICS network and learn about what's there. At that point, I'll get on to the next slide, but you've got an initial point where you just get to the ICS network. There's a lot of work that just happens at that level just to get there. That's what we call stage 1 of the ICS kill chain. It allows the attacker to get to the point where they can perform reconnaissance against the ICS environment now to develop the attack against that. I'll bring this up quite a few times throughout this talk, but that IT-OT boundary, in stage 1, the attackers are going to cross that boundary into OT, or just get right up and through that boundary. Often, very often from the business network, sometimes directly from the internet, although we hope not, but remote access and business-to-business partner connections, vendor connections, those are a huge source of access for malicious actors. That's how they're going to initially get across that boundary into OT. And that's going to speak to some of the things we want to do to protect against them in the future. Now, what this means is attackers tend to land on familiar systems, on Windows systems, because that's what we tend to have at the boundary. And attackers like this because they're familiar, they're well understood. We have a ton of Windows attacker tradecraft out there. And the attackers, they don't need a deep understanding of process control if they can just click buttons on a Windows system, right? In Destroyer, the first one in 2015, ultimately the attackers were controlling a Windows system with remote desktop assistance, no less, and pushing buttons to shut things down, like clicking things on the screen. That didn't require any sophisticated knowledge of control systems, really. I mean, understanding that you're on a system that can open breakers and cause an outage, sure, but that was it. So this is going to start to inform our defense, at least the initial layers of our defense. So an attacker lands probably on this Windows system at the IT-OT boundary. What's next? Well, now they're going to perform reconnaissance in the ICS network. So they're going to want to maintain access to the extent they've got it, but now figure out what's there on that ICS network and develop a target-specific attack. If you spend any time in ICS, you'll know that, yeah, we do a lot of the same sorts of things from organization to organization. And yes, there are common vendors and common tools, but every single environment is different. So an attacker has to develop some target-specific knowledge and capability. And they probably are going to want to build that in a lab and test it offline and validate. I mean, we're going for real-world impacts here. You don't just want to, throw a Hail Mary and hope it works. Once it's tested and validated, then they have to deliver that payload to the ICS network, maybe over the existing command and control, through the existing foothold, but that payload has to get there and then be executed, and then if everything lines up, then the bad thing happens. So this means something else for us. If we can stop that attack anytime before this point, basically, before the delivery, even the delivery maybe we could argue is okay, but before the installation and execution of the attack, we're actually winning. So we need to keep that in mind from at least a starting point on the defensive side, right? We want to stop them anywhere in this range. Obviously, as soon as we can or as early as we can, but we've got a lot of opportunities here to detect and stop attackers. And that's what we need to be thinking about. We win if we stop them before that line. And remember, again, most attacks, I've told you I keep saying it, originate on the business network or the internet. Yes, physical access, USB, bunch of other risks, yes, but vast majority come through that business network. This helps us inform what we want to do for defense. Before we get to defense, though, let's talk about our risks. What are we trying to prevent? Well, we kind of talked about it. We don't want stuff to blow up. But we have our standard business risks, and these still apply. We don't want to lose access to business applications that make the business work. We don't want ransomware, data corruption, loss, that kind of thing. And we definitely don't want brand or reputational impact. Those are things that can happen whether we're talking about an ICS attack or not. But in an ICS world, we have much more critical, certainly impactful things that can happen as well. If we lose visibility or control of the process, and again, bad things could happen. Things can explode, leak, burn, whatever it is. Obviously, a manipulation of the physical process could cause those same things to happen. Could cause risk to people, to environment, to both. And of course, if we're talking about ICS, unless we're talking about kind of government operated or, like think water treatment, for example, it's not a profit center for a municipality, for example, but it is absolutely critical. But most in the corporate world, most industrial control systems, they are the lifeblood of the company. They're the economic engine of that company. And therefore, any loss of production or operations can have massive financial impacts as well, to the point where a company can easily go out of business. So these are risks, these are big stakes that we are trying to mitigate or protect against. What are our common exposures? I've touched on a lot of these. That business to ICS connectivity, that IT-OT boundary, right there, that is one of our biggest risks, our biggest areas of exposure, as I've been saying. But remote access and vendors, the nature of these systems is they're old. We might not have people who understand how they work anymore. They could be decades old. They're very specialized in a lot of cases. Vendors don't always like to share information about them. So there's a ton of remote access. We want to be able to operate them 24/7. So just for that reason, ton of remote access connections to vendors. As we know, bad things can come across those connections. That's a huge exposure as well. Internet connectivity, whether authorized or unauthorized, we want to minimize it, obviously, but sometimes there's unauthorized internet. That's a huge exposure. And once an attacker has access, a lack of segmentation, an inability to contain any sort of pivoting or movement through the network by an attacker. And of course, if we don't know that something bad is happening, well, that's bad in and of itself, right? Insufficient monitoring. We don't tend to have IT or cybersecurity monitoring in OT networks to the extent we do in IT networks anyways. We might monitor the process, but not necessarily the technology around it. These are the risks we're trying to mitigate. So let's raise the bar a little bit. That's why we're here, right? Let's start with the sliding scale of cybersecurity. There are a lot of things that we can do to protect ourselves. And we start on the left here with architecture, right? Now, you're going to tell me, well, we've got an environment that's been operating for 40, 50, 60 years. Who knows how long? Maybe not that long, but some of them are. We're a little past architecture. Yeah, maybe you are, but that's still something we need to, that is still where we need to start. It's just we can't rip everything out and start over all at once. We have to work our way backwards. Obviously, architecture is fundamental. If we architect our environments appropriately, it makes all the rest of the security much, much more straightforward to implement. Passive defense is where we are at. This is where stereotypical cybersecurity looks like, right? This is systems added to the architecture to provide reliable defense or insight against threats without consistent human interaction. Humans might set it up, but we're not going to be there, interacting on an ongoing basis at the passive defense level. This is all of the tools the toys you can go to market and buy, right? Start with firewalls, just as an example, right? Any of those toys you can buy, plug in, and magic happens, hopefully. But no, really, even if, usually we're talking about humans configuring them, that's our passive defense. We buy a firewall, we put it in place, we segment the network, that's part of our architecture, and we put firewall policy in place to control access. And as long as we don't screw it up, that defense is there, the firewall's there, and it's continuing to provide that defense without human interaction. As we mature, we get to active defense, which is the real people part, where people are monitoring, responding, and learning from the adversaries. It's more of a dynamic, situation where we can actually detect and observe and see what's going on and react to that. And it doesn't just stop at the detection. It's going back and interacting with the environment to make it more resilient, to get rid of the attacker, to get them out, to section them off, and so on. And as we mature, we can also augment that capability with intelligence that is ideally specific to us or our industry. And then offense, not hacking back, but legal countermeasures, self-defense actions. That could be involving law enforcement. That could be doing something for attribution to figure out where the attacker is so that you can do something in the real world. Or these are the countermeasures that you are taking to protect yourself. It's still protecting yourself. It's self-defense. It's not hacking back. Let's look at this a different way. Bang for the buck. Everything in cybersecurity has to do in some way, shape, or form with bang for the buck, right? At the bottom of the blue pyramid anyways, we have architecture. Lots of value in architecture done well. And done well and early, relatively little cost. It doesn't cost a lot of money to draw fancy pictures, or not so fancy, use your napkins. And then, again, if we're starting from that point, implement technology or tools to align with that architecture. And even passive defense. There is a cost in purchasing all of these fancy tools and blinky lights and so on and so forth. But again, we get significant value compared to the cost of that passive defense. And as we move up the value chain here, though, active defense, I mean, there's still absolutely value there, but not quite as much. We don't get the same bang for the buck. Our cost is increased for slightly less value. That doesn't mean we don't do it. It's just let's start with the easy things and build up from there, right? And of course, intelligence and offense have lesser value as we move up and higher cost to do well and to do right. So we want to focus on, I'll be talking today about the bottom two levels of the value proposition here. That's where we can have the biggest impact, and we can have an impact in an ICS environment. No matter how difficult it is to get a toehold in there as a defender, there are ways we can have impact for sure. So what should you do? This list actually came from the Dragos Year in Review report, and I thought it did a really good job of bringing up to a high level and summarizing the steps that you should be taking as a defender. And the first one, shocker, is building a defensible architecture. So keyword there is defensible, though. This is the point with architecture. This is where you get the value. If you can architect, for example, your networks with strong segmentation, then that gives you the ability to control communication. And that segmentation also gives you choke points where you can monitor. So that defensible architecture, it's implementing your networks and your systems in such a way that it's easy to apply additional security controls, right? Network monitoring is key, especially network monitoring. We have a whole variety of systems in ICS. A lot of them old, a lot of them turnkey. We may not, they may be commodity operating systems. We may not have access to them. They may not be commodity operating systems. They need to work in a deterministic fashion. So we may not be able to borrow CPU cycles to do anti-malware things. That leaves us with the network where we can have the biggest impact. So we absolutely need that network monitoring because we're not going to be able to touch all of the endpoints in an ICS environment, no matter how much we try. Control of remote access and authentication. That's kind of two pieces because we care about authentication throughout, not just for remote access. But obviously, all of the contractors and vendors and staff who are coming in via remote access, that's a huge exposure that we need to really control, authenticate, and authorize appropriately. We want to manage key vulnerabilities, and that word key is important. Vulnerability management is a tough conversation in most worlds, IT, let alone OT. So we need to be selective, but we absolutely do need to manage some vulnerabilities and know what's going to happen when something goes wrong, when we're under attack, or maybe it's not malicious, but something's gone wrong. A lot of ICS environments have pretty robust plans for when something goes wrong in the real world, a leak, a fire, whatever, right? And they think they're prepared, but very often these safety assessments and incident plans and so on don't take cyber into account. Number one, they don't account for the fact that cyber could cause the incident. And I keep saying cyber, I'm trying to stop, but that they could cause the problem in the first place. But also that that electronic systems can be a part of the solution or can be the thing that's actually impacted and that we need to recover. There's so much there that isn't necessarily taken into account in a lot of incident response plans. So you absolutely need some capability to gather information, to figure out what's there, to contain the damage, to respond and respond to an incident. These are the top 5 things, 5 categories of things to keep in mind. This is the starting point for ICS security for everyone. This is where we need to begin. But I can't. I've been here for 40 years and nothing has gone wrong yet. Why do I need to change anything now? Well, I'm making $1 trillion every second. I can't stop now for you to do some security stuff. I'm short-staffed. Do you know what it's like getting people to come work at the top of the mountain in up north in the snow and rain and sleet and whatever? I don't have the people. They don't have the time. They have other things to do. They're busy making me money. We don't have time for security. I guess that's the other priorities as well. We need to make more money, do more of the thing, manufacture more of the thing, whatever it is. Yeah, we could put that in. We could do that security thing you want to do. But how do we know a year from now it's not just going to blow up and cause a major outage? Well, we've along the lines of it's been operating for 40 years. Well, what tools do you have that can work with my 40-year-old stuff, right? Or maybe you can. You've got some great capabilities over here, but guess what? This is a plant. It's not just one system. It's a system of systems of systems from multiple vendors installed and managed by multiple different people. And if you touch one thing, you touch them all, and we just can't do that. Or maybe the vendor says, you're not going to touch my stuff. We got this. We got this. You're not authorized to make changes. We're not going to support you if you do anything to change our default deployment, which of course is deployed for safety and operations and reliability and making money, not for cybersecurity. So there are, if you go out and talk to an engineer or an operator, there's lots of reasons you can't do anything. This list is actually a short one. And this is what we have to overcome. That's part of what we have to do. So what can you do? You know what? I know it's a bit trite, but it's a marathon. It's not a sprint, right? Let's get better. Let's do what we can to get better. Everything in ICS is planning for the future, right? On the extreme end, you think nuclear. You may be in planning and design for 10 to 20 years before a nuclear reactor facility goes live. So it's okay to plan for 5 years from now. I'd like to see some incremental improvement along the way, but it's okay to take that gradual approach and plan for the future. Architecture, I didn't put the air quotes in there, is free. You can certainly start, again, building those best case templates and so on and so forth, knowing what you want it to look like in the future so you can start building towards that. Virtualization is giving us a lot more tools to reduce impact, to reduce interruption, to reduce downtime, to recover if something does go wrong, snapshots and so on. Vendors are being forced and are choosing to come to the table. We just have to get on their latest and greatest or newer stuff. You've got new initiatives. There's always an acquisition or a new plant or a new well or a new city or a new substation or a new something. Start there, right? It's something, and use that as your model and move from there. The C-suite is certainly much more aware of cyber risk to ICS. So there's it may be misdirected at times. It may be hard to actualize and to realize in the real world, but there's certainly more buy-in from the C-suite. There's more visibility. And you know what? We don't have to touch the process. If you really dig down, there's lots of stuff that's critical. Don't get me wrong. But it's still this stuff over here that's critical. This is the stuff that is cranking out the electricity or whatever it is on a 24/7 basis. This stuff over here, it helps us. It helps us charge people money. It helps us monitor. It helps us see as human beings what's going on. It helps us track efficiency and tune and so on. But it's not part of the process directly. Maybe we can start there and start securing at the boundary. Because remember, I made a big deal out of this. The attacker is coming in through the boundary. Your core process is not at the boundary. So let's start there. And of course, visibility monitoring in and of itself is not disruptive. So start. Use that monitoring to get your asset inventory, to figure out what you're dealing with, and go from there. So I kind of spoiled some of this, but here's where we start. Architecture, right? High value, low cost. Let's, like anything in IT and especially cybersecurity, what does good look like? All I want you to do, and I forgot I was on this slide. Before we start here, I'll get back to this. We need relationships. This is the thing I forgot before we get to architecture, although not really before, we can do it in parallel. But the one thing that you will not succeed at bringing any security to an industrial control environment if you don't have relationships with the people on the ground, so to speak, with the operators, with the engineers, with the technicians. If you don't have a good working relationship, you will not succeed. I had my best success when we spent over a year just helping out in the OT environment. Not doing security, just helping, make things better, improve technology, figure out VMware and storage and so on, and learning and meeting people and making relationships and understanding the business drivers and the requirements along the way. That's where we've started. I even jumped the shark here a bit and got ahead of myself. We need to start with the people side of things. If we can't speak to why it's important, but why we're not going to screw things up, we're not going to cause an outage, you might actually be more safe as a result of the work we're doing. We need to do this in a nice, in a collaborative way. We can't just come in and preach the gospel, right? So relationships, if you don't get those in place, you can't start there. So where to start? Figure out what good looks like. Again, anytime I talk to anybody about anything in cybersecurity, you know what? Let's set a target. What is our goal? Where do we want to end up? And let's start with the easy or gradually. How about every decision you make from now on, you look at it in the context of where you want to be in 3 to 5 years, and you try not to move further away. Even maintaining the status quo is kind of a win. Let's try to move a little bit closer though, right? So let's develop those templates for where we want to be so we can articulate it. So when we bring a new site online, we can use that template and we can at least get that site looking the way we want it to. So that when we have scheduled maintenance or are deploying new systems or whatever, we can align with what good looks like and get there over time. It's a long game. So the new site refresh, and again, start at the IT, OT, internet, remote access, vendor connections boundary. Those systems there, I mean, everyone will jump up and down and tell you how critical they are, and they are important systems. But a screw up there is not the same thing as a screw up at the process level, right? We can start there. We have commodity operating systems, mostly Windows and traditional networky stuff at this layer. Let's start with that and then move on from there. That's architecture. Some of the things to consider. Hey, how about we actually talk to people and figure out what the requirements are, both for security and for the business. We might know, okay, we produce electricity or oil and gas or widgets or whatever it is. So the business drivers should be obvious, but they aren't always, right? Understanding what drives the business, what's important to them. It's a little bit of a cliche as well, but what that really bad day looks like, because you can't protect it all. So what are the most important things to protect? If we show up on site and safety systems are on the network, well, we start there. They should never be on the network. Those are your fail-safe for when things go bad on the network. Like that is number one, right? Safety, business operations. Figure out what the requirements are, and then I'll talk about labels a bit more here. Slap a virtual, I don't mean slap a label on everything. Slap a label on everything virtually. Know what it is, what it's for, what its requirements are, for availability, for access, for security, for operation, all of that. Know what you have, right? First couple critical controls, it's just another way of saying it. Know what you have out there, what it's for, group them together so that you can deal with them in a priority fashion in groups. Build out you're architecting at this point, so design that strong IT-OT boundary with DMZ, with remote access, including vendor connections, partner connections, all of that remote type stuff. File transfer as well, a secure way to get files in and out. Segment your network. So you've grouped everything. So based on those groupings and labels, you want to architect your network such that things that are grouped together are on a common network, but that we've got a segment, a boundary, enforcement of communication or flow of communication between those different segments, so we at least have the opportunity to introduce some level of control. And in doing all of this, it kind of happens naturally, but ensure that you have a way to get visibility, whether that's with a tap, a span port, net flow, all of the above, firewall logs, audit logs, ideally all of it. So make sure you have a way to get visibility, a way to monitor, and a way to respond, a way to act. You've architected an environment where you can see what's going on and you can act when you need to. But architecture only gets us so far. Before I move on to the passive defense, this is based on the Purdue model, essentially. This is the Purdue model. We've got our level 0 through level 5 systems. We've got our enterprise DMZ at the top, safety at the bottom. I'm not going to spend a ton of time going through this, but I just put this in here to reiterate, this is what I mean by labeling. I can tell you, I can sit here and talk to this for a while, and I'll come back to it later. Here's where I want firewalls, enforcement boundaries, segmentation, segregation. Here's what DMZs need to look like. I can't do any of this unless I know what my level 1 systems are. What are my DCS and RTU and PLCs? What are my aggregate historians? What are my local historians, et cetera, et cetera? This is again back to the inventory and labeling. Until I know what these things are, I can't segment them. I can't architect a network to protect them. The Purdue model gives us great guidance just for labeling. That's all it is, in my opinion, is a way to slap these labels on. Sensors and actuators, level 0. RTU, PLC, DCS, level 1. Communications gateways, local historians, alarm servers, HMIs, level 2. A lot of the other stuff, level 3, chunked into different chunks. And if I have my asset inventory, I have my visibility, and I've put level labels on everything, now I can start to build firewall rules and written policy that said this is the kind of authentication, or this is the kind of backup or virtualization or whatever it is. That's why I'm harping on the inventory and the labeling, because once I have that, then I can draw generic pictures and I can build those templates to tell me how to protect the different classes of devices. Some key tenets from an architecture perspective. We do not want internet in our OT network. There are very specific exceptions where maybe we need to download something on a regular basis. Well, then we should have a proxy server that allows that and nothing but that. If you need email, internet, web browsing, other things, then have a dedicated business computer. I've been talking a lot about the enforcement boundaries, so I won't spend too much time on this, but we want separate authentication. We don't want to be shared with the corporate network, including MFA for all access into ICS. We need to provide a mechanism to transfer files securely without malware. It kind of goes without saying, but let's try a deny by default and permit what we need. And these enforcement boundaries are an ideal point to monitor and log communication in both directions. Use AD. As much as parts of me kind of cringe when I say this, we have a lot of windows in ICS networks. Leverage an Active Directory, not your corporate Active Directory, completely disconnected and not managed by an engineer, managed by someone who understands AD. But it gives us group policy, it gives us authentication, a lot of security controls that we can leverage. And then manage the antivirus, patching, all of that stuff on the OT network separate from the business network. That brings us to passive defense. These are the 5 categories. They're kind of somewhat tied to the 5 things you should do that I mentioned earlier of passive defense that I'm going to talk about anyways. Enforcement boundaries, again, I'll move on. Authentication and authorization, though, is a huge part of our passive defense. Protecting our endpoints to the extent we can. Getting our visibility, our monitoring, our logging, and then managing those vulnerabilities, patching. I will get there. That's always a fun conversation. So at the enforcement boundary, it's generally easier, as I mentioned, to apply security at the network layer. Start with that IT/OT DMZ boundary. Segment the OT network further, though. Put your Active Directory systems, your jump servers, your security-related systems, your antivirus systems, your engineering workstations versus your operator workstations, whatever. Group them together on dedicated networks so you have at least an ability to control access, right? Even if you're not today, at least segment so that you can get there in the future, and then enforce that policy at the network level. We want also to have a minor enforcement boundary between levels 2 and 3, and sometimes within level 3, to help us contain access, to stop the pivoting and contain a compromise. And as I mentioned, manage that remote access and file transfer. So popping this up one more time, what I'm getting at is we want this red line here is a minor enforcement boundary. It might be an access list on a router or something, but I'm separating level 2 from level 3, or I have the ability to, and I'll come back to that on the next slide. Maybe I take my engineering workstations, my jump servers, Active Directory, all the things I talked about, and I put these on different segments within level 3 so that I can have finer grained control of communication back and forth. Obviously around the DMZ, possibly multiple DMZs, so it's one of our primary goals of this DMZ, without going too far into the weeds, is so that we can't get a single bidirectional connection like command and control. If you think about command and control, we want to prevent that. So if you want to move data from level 4 down, it goes through this DMZ, terminated on a system here. If we want to move it up, completely separate DMZ. So now your ability to have bidirectional communication is minimized. It's made much harder. So we want these enforcement boundaries at multiple points here. And this is a slightly different view. If you look at a wide area network, I might have a plant network, some remote substations, well pads, whatever they might be. I also want the ability, if something bad happens here, I want to prevent that from impacting the rest of my network. So by having an enforcement boundary between levels 2 and 3, I can then isolate this site and prevent it from being impacted by other sites or impacting other sites. I can cut off, or if I have an IT, a compromise coming in from the business network at the IT level, well, I can cut off below level 3 or cut off the field, let them operate on their own, but again, containing the damage, continuing to operate in a minimum viable state, right? We don't want to run in that state all the time, but if we have a minimum viable state and we have a process and a way to reduce our footprint to that in order to contain something bad, that's perfectly fine, and that's something we want the capability to do. All right, enough about enforcement boundaries. Authentication and authorization. I talked about a dedicated AD and leverage that centralized authentication, LDAP or ICS Attacks, whatever it is, so that we don't, because we have lots of contractors. We have lots of transient people coming in and out of ICS networks. Local accounts, shared passwords aren't ideal. Those passwords go spread far and wide. If we centralize, one, we get logs of every action people take or every login at least, because it's centralized. And provisioning and deprovisioning are so much easier. We want dedicated OT accounts, but we want those tied into corporate provisioning so that if someone leaves, something actually gets done about it. Privileged access in OT networks is just as important as in IT networks. I've seen many an OT domain where every single operator was a domain admin. We want to control those kinds of things. We want network level controls so you cannot connect to management interfaces unless you're supposed to. As I mentioned, limit the generic and shared accounts and secure that remote access. So I have a whole different webcast and blog post on secure remote access, but multi-factor, dedicated credentials, minimum access, separate people by roles. There's a whole bunch of stuff that we can do there. Endpoints, where we can, again, close to that IT/OT boundary, where Windows proliferates. We want to leverage Active Directory, group policy for those security controls. Have a secure baseline so that we can pull a device off the shelf and see what's changed, so we can do incident response, so we know what good looks like. Again, back to the new site, new location, new deployment, greenfield type scenario. How about these are static environments. Partner with the vendor and lock these systems down as much as you can before they go live, before they're deployed. Get that secure baseline. Application control is absolutely doable in that context. AppLocker, for example. Work with the vendor. It's a static-ish environment, so get that done where you can. Certainly use anti-malware where it's permitted and possible. Endpoint firewall. So I talked ad nauseum about segmentation. If you can't do it at the network layer, do it at the endpoint layer. Everything should be fairly static, and you can validate that during your site acceptance or pre-deployment testing, right? There's a lot you can do there. And of course, visibility, monitoring, logging. Passive monitoring, that's where we start. We're not talking about scanning. You can do it very, very, very carefully. Ideally don't, but sometimes there are legitimate reasons to be scanning. But just look at what's coming by on the network. We can tell a lot from that. So set up your enforcement boundaries, your checkpoints, so you can get that visibility. It'll build your asset inventory. It'll tell you about vulnerabilities in many cases. It'll tell you who's talking to who, help you build that those network segments, your segmentation model and your firewall model. Maybe you'll find the vulnerabilities and improve that logging maturity. Logging in OT is almost always much worse than in IT. And the way I like to look at this is levels of maturity for logging. I won't, again, go into massive detail, but let's call 0 no logging. That's the worst. 1 would be, I've got logs, but they're all over the place. They're on local devices. I don't do anything with them, but they're at least logging. You know what? Great. At least I can show up and get access to logs and see what happened as opposed to not. That to me is awesome. 7 days worth of logs is way better than nothing. Now, ideally, we would like it well configured to log appropriate things for incident response. That's another level of maturity. And then we'd actually like to centralize those logs to make our lives easier. And you know what, if we're going to centralize them, we kind of want them in something like a SIM or a database, whatever, a searchable place. And maybe we want some use cases and automatic alerting against that. And then people actioning those alerts and looking at the logs and then correlating between multiple sources. You see, there's many levels there. Honestly, get logging enabled and maybe collect it centrally. I'm going to be ecstatic in an ICS environment. And I mean logging from the process, logging from controllers, administrative access, and your traditional Windows firewall networky type remote access logs. Got a few minutes left. Vulnerabilities and patching. I can't do this justice in a few minutes, but first thing to recognize is not all vulnerabilities need to be patched. We are dealing with environments where controllers do take action with 0 authentication. In that environment, it doesn't really matter if it's vulnerable, if it will do anything I tell it to do. So let's start with not worrying about that stuff. Okay? And then let's also recognize that when it comes down to the actual control systems, 2 things. 1, they're going to be really hard to patch. It takes more work, outages, diligence, etc., testing, validation. And 2, with exceptions, obviously, to get to those systems, coming back to my attack chain, the kill chain, sorry, and landing just inside the IT/OT boundary on those Windows systems. You're coming through the Windows systems to get to those, you're coming through the level 3 systems, basically, to get to the lower level systems to attack them. So let's start by patching and locking things down at that level 3, level 3.5, IT/OT boundary, DMZ. It's also much easier to patch Windows systems. I was talking to a customer, about their patching and how they keep things up to date. And, they had some understandable gaps where they couldn't bring systems down, but their domain controllers had never, ever been patched. There's different categories of systems. I get it when you can't patch certain things, or certainly not as much as you like. But your DCs, you've got multiples. Like this stuff, that is the keys to your kingdom. That kind of stuff needs to be done. You've got redundancy. Patch one half, then the other half. You've got virtualization. Again, I'm not talking about the process itself necessarily, but patch, if there's a problem, roll back. And I'm not saying it's easy, so prioritize those things like the domain controllers, the jump servers, the stuff around the edges. That's where we need to focus. I won't spend too much time on this because I want to leave a few minutes for questions, but here's an approach to patching, right? First, does a patch exist? Does it affect me? No, don't care. Is it an emergency patch? So we need to categorize it? Yes, okay. If not, we're not dealing with it right now. It's an emergency patch. Does our operational need outweigh the risk? In other words, does the impact to the business from the act of patching or from the act of having patched and causing an outage further down the line, does that outweigh the risk of the vulnerability being exploited? It's a decision we need to make. If operational needs are greater, then again, we're not going to patch right now. If operational needs are not greater, we think the risk is significant, look for an alternate mitigation. If that exists, well, mitigate and exit. Only if we go all the way through to the end here do we patch immediately. And for many organizations, there are caveats to that patch immediately, but we're going to try and do something. And then, of course, if we didn't, then we patch during the next window. Either way, we document and continue, right? It's just a way to think about the patching process. It's very much not an all or nothing thing, but it's also very much not a nothing thing. We need to do something, manage our risk as best we can. So patching is important to a point. Vulnerabilities are important to a point. It's something we have to be aware with and deal with. Sometimes that might be this next window, might be a year from now. And that may suck, but it may be okay. And that's when we focus our efforts at the boundary so that nobody can get there in the first place. So to wrap up, we want to strive for that active defense. I purposely stopped short of active defense here. I kind of see architecture and passive defense as our minimum viable for defense, and we really want to start getting into that active defense, which is the repeated actions for ICS defense analysts, monitoring for, responding to, and learning from adversaries internal to the network. So it's humans acting on threats. That can be through threat intel, consumption, getting visibility, detecting a threat, responding, and then changing things to protect ourselves. Just to recap again, we've got this sliding scale, right? Let's focus on these two here. Start with our architecture and our passive defense. There's a ton of work to do here, and we can do it. Overcome those objections, build those relationships. Start small, help where you can, and even if it's not to do with security, build the relationships, and small baby steps, gradually get better, and strive to at least get to some of this middle territory and see if you can get beyond that. Different view, bang for the buck. Again, just reinforcing that this is where we have our bang for the buck. So we want to focus on that architecture, and it's a long game. You know, we're going to do the architecture so that we can be better positioned a year, 2 years, 3 years from now. That's okay. Right? The worst thing we can do is just say, it's hard, it's risky, I can't take an outage, I'm not going to do anything. We need to start planning. We need to start building that mind share, building that momentum to do something, to get better. That's where the bar is at right now. When I talk about raising the bar, it's kind of down here. I just want to, let's get the bar off the ground, right? Let's start there. And no offense to anybody who has done that already, but by and large, our ICS security bar is pretty close to the ground. No one's limboing under that thing. Just final slide to leave you with these 5 core defenses or things you should be, areas of work you should be focusing on from a cybersecurity perspective. Defensible architecture. We want to build a network that we can defend. To do that, we need monitoring. We need to be able to see what's going on that network. Remote access, access control, authentication, that boundary, that entrance point for everybody, absolutely something we need to control. Key vulnerabilities, the ones that can really hurt you, we have to prioritize. We can't do everything. So let's manage them. And it's going to happen. Be ready to respond from an IT, from a cybersecurity perspective, and absolutely integrate that with your business continuity and disaster and your incident command structure and all of that. But recognize that the IT or cyber world can be the cause of an outage, and its loss can also, in and of itself, it can cause you an outage, so you may have to do incident response, but it may also be integral to responding to a different kind of incident in a different area. So all of that, or related incident, all of that is important from an incident response perspective. So I left 2 minutes for questions. Apologies, not quite there, but if anyone has any questions, please let me know. Put them in the chat. You can find me on LinkedIn and other places, and I will share these slides as well. So I hope you enjoyed that, and I hope to see you out there lifting that bar, and hopefully the weights on the end of that bar are not too heavy. And yes, don't forget the relationships. Thank you very much for that comment. Absolutely where you have to start. If you don't have friends, you're not getting anywhere fast. Yeah, patching is not the only answer. There are key patches we need to get in quite often. Domain controllers is an example. But yeah, it's an insecure by design environment. Patching doesn't help with that. Other things help with that. So let's be selective. Use our energy wisely. Honestly, the operators demanding testing in a like environment, so I ask them, where is your like environment? Because you're making changes all the time. And then they scowl at me and we agree to disagree and whatever. But putting that aside, there are scheduled outages, there's scheduled maintenance, and we need to make security part of those scheduled maintenance outage windows, because at the end of those windows, usually they have to go through site acceptance testing again. So that's the time where we can really do a lot of these things, is during, especially at the lower levels, during those regularly scheduled windows, or pre-deployment. Partner with the vendor. There's nothing wrong with saying to the vendor, hey, you know what? We're going to do a bunch of security work for you that you can reuse with other customers, as long as you're willing to work with us and build this out and land in a better place. But it almost exclusively has to be done pre-deployment. So focus on those brand new sites or those site refreshes. We can do enough work in those areas that we can make that improvement over time without having to worry about the sites that we can't touch today. That'd be my take. It's not perfect, but there's sites you can't touch today, and that's going to be the way it is until you've proven the solution in other locations. All right, thank you, everyone. I'll hang out to see if there's any other comments just in general in the chat, and hope you enjoyed that, and I'll, like I said, see you out there raising the bar. And thank you all for coming. Forgot to say that, so thank you.